Hello, this is Mr. Henry, and welcome to lesson 1.1. We're going to be evaluating expressions. The essential question says, how do I evaluate algebraic expressions and use exponents? Down below here we have 3 get the goofs. What we want to do is try to figure out what mistakes there are in these problems. So let's look at example 1 here. 18 minus 9. Does that give us 11? No. 18 minus 9 should actually be 9. 15 times 23. So if you did this and you did like the 3 times the 5 is 15, and you carry the 1, and then 2 times 1 is 2, plus 1 is 4, it doesn't work out so hot. Or another thing is some people forget to drop down and add a 0. So if you multiplied by this 3, and you took 3 times 5 is 15, carry the 1, 3 times 1 is 3, plus 1 is 4, dunk. Then when you drop down to the next line, when you're multiplying by the 2, you add a 0. 2 times 5 is 10, carry the 1. 2 times 1 is 2, plus 1 is 3. Now you add it all up, and you get a 5, a 4, and a 3. 345 is the solution there. And number 3, see, 3 goes into 14 4 times. 4 times 3 is 12. Subtract, you get 2. Bring down the 4. 3 goes into 24 8 times, because 8 times 3 is 24, with a remainder of 0. So that one is actually correct. We have a couple vocab words, more than a couple. We've got like 5 vocab words here. So let's go ahead and get them in. A variable. A variable is a letter used to represent a number. The problems we're going to see today and throughout this entire Algebra 1 book, you're going to see a lot of times where we're using variables like x's and y's and a's and b's to represent numbers. An algebraic expression is an expression that includes at least one variable, as I think every single problem today will be. These next 3 words are all relating to exponents. So first off, we have the power. The power is the base and the exponent together. It's the 2 parts. So here's what I'm going to do. Off the side of my paper over here someplace, I'm going to write down the power, maybe 7, 3. So this whole thing from here to here, the big guy and the little guy together, is called the power. The base is the bigger number on the bottom. So the base here in green, or that's red, is just the 7. And then the exponent is the little number on the top, and that one will be green, is that. So power is the whole thing, base is the 7, 3 is the exponent. Alright, so let's look at a couple of these problems, and you'll see that these should all be fairly easy. So here we have c plus 8. Now, if that's all the information they gave us, we could not do anything with that problem. But because in the directions they tell us that c equals 12, well then we can plug that 12 in for c. Everywhere you see a c, you plug in 12. This is called substituting. And then you evaluate. Evaluate means to do the math. So 12 plus 8 is 20. And that would be done. Letter B, same 2 steps. We're going to substitute and evaluate. So in letter B here we have a times 6. Well, a is 4. And 4 times 6 is 24. Letter C, 8 minus b. So that's 8 minus 5, because 5 is what b is, and then you subtract and you get 3. Okay, so simple enough. I've done 3 problems. I'm going to have you do the next 2. It's using the same A, B, and C. So please copy down letters D and E on your note sheet, and then do the math just like we've done here. I'll go ahead, pause the video, do those problems, hit play when you are ready to continue. All right, you should be done. So let's see. Letter D says 3 times B. This is a multiply. That's a multiply that a lot of people get confused about. They don't understand that it's a multiply or why it's a multiply. Anytime you see a letter right next to a number, or even a couple letters right next to each other, those are multiplications. So this says 3 times 5. And 3 times 5 would be 15. And the last one here is C divided by 4. Well, C is 12. And 12 divided by 4 is 3. All right? So that's evaluating an algebraic expression. You substitute to get rid of the number or to get rid of the letter, then do the math. We're going to see a word problem or two. Here we have letter F. It says, James mowed his neighbor's lawn. The money he made can be found using the expression 2.5h, where h is the number of hours James mowed. How much money did James earn if he was mowing for 3 hours? So the first thing I like to do is I like to figure out what it is I have to do. I need to find out how much money did James earn. That's my final goal. All right. Now, the other important information it gives us, it tells us he mowed for 3 hours, and it even says the money he made can be found using this expression where h is the number of hours mowed. So if we use that expression, 2.5h, and we know that the h, the amount of hours he mowed, is 3 hours, we substitute 2.5 times 3. By the way, this is another way to show multiplication. Two numbers next to each other with parentheses around one of them. And 2.5 times 3, 2.5 times 3, 3 times 5 is 15. 3 times 2 is 6, plus 1 is 7. You'll notice here I am not lining up my decimals. You do not need to when you multiply. I have one number after the decimal in the problem, so one number after the decimal in the answer. This guy earned $7.5 or $7.50. Okay? And the last thing to check is just, does your answer make sense? Does it make sense if he earned $2.5, I guess, each hour? $7.5 for the total. Does that make sense to you? I think so. Letter G. You are ordering a skateboard and a helmet from an online store. The total weight of the two items can be represented by S plus H, where S is the weight of the skateboard and H is the weight of the helmet. Find the total weight if the helmet weighs 1.3 kilograms and the skateboard weighs 5.4 kilograms. I want you to do this problem on your own. Pause the video, write your expression, do your math, get your answer, and then we'll get back together in just a second. Okay, you should be done, so let's see. We have the given information it gives us here is S plus H is the total weight. It tells us, it wants us to find the total weight. So the total weight can be found using this thing. Okay, so we're going to use that thing where S is the skateboard and H is the helmet. Got it. Now, do we know what S and H are? Well, the helmet weighs 1.3, so that's 1.3 over here. The skateboard weighs 5.4. 5.4. Now this is our total weight. So if we add these two things together, we'll get our answer. Well, 5.4 plus 1.3, 7, 6.7, and our label is kilograms. So we wrote down the expression, we substituted, and then we evaluated. The last thing is check your answer. Does that make sense? If this guy's carrying his helmet and his skateboard together, Do these two things together look to be about 6.7 kilograms? The answer is yeah, that makes sense to me. Example 2. Now here we're going to look at exponents. So, the way you do these powers and exponents, now here it just says to read and write the powers. It does not actually ask us to evaluate. So the way we would read this, we would say 4 to the third power. That's how you would read it. You could also say 4 cubed. Cubed is another way of saying to the third power. So these are both ways you could write this down. Now, I guess you could also use all words instead of using the 4, so like F-O-U-R to the third power, like that. I mean, this is the same as that, but with all words instead of numbers and stuff as well. Now, what does this actually mean in terms of math? We know how to write it and say it and all that kind of stuff now, but what does that actually mean? A lot of people get themselves confused and they think that means 4 times 3. So they say, oh, what do you get if you evaluate 4 to the third power? And a lot of people jump on it and say the answer is 12. But that's not right. The answer is not 12. 4 to the third power means you're going to take 4 times itself 3 times. So you're going to have 3 4s. Now, this problem does not ask us to evaluate. We're not trying to find the answer yet. But just to show you here, if we would actually do this multiplication, we're going to get 64. 4 times 4 is 16, and then 16 times 4 is 64. So I'm trying to show you that it is not just 4 times 3. We have other ways of showing multiplication. That is not one of them. Okay? Letter B. Now, the way we would write this, I'm going to use all words. Write 6 to the second power. We could also, this little guy, the 2, has another name. We could say 6 squared. And by the way, those are the only two that have special names. Squared and cubed. Everything else is to the 4th power, to the 5th power, to the 19th power. Okay? So there's 2 different ways of writing this. And then, what does this mean as math? Well, this says 2 6s. And you multiply them together. Now, we're not actually going to multiply here. You don't have to. That's what you should get. So this is what it means in words, and this is what it means in terms of math. I would like you to do letters C and D right now. Pause the video, copy the problems down, do them on your own. You'll see letter D is a little bit tricky, but you might still get it. Go ahead and do it now. Okay, so you should be done. Let's check them out. So the way we would write letter C is we'd say M to the 5th power. There should be an extra F in there. 5th. All right, now, M to the 5th power. That is literally the only way to write that. I guess, well, you could also say M to the power of 5. I really don't like this one, and most people don't use this one. They'd say M to the 5th power, not M to the power of 5. But technically, this one is correct as well. Now, how would we write this in terms of math? Well, in terms of math, it would be 5 M's. So 1, 2, 3, 4, 5, and then we multiply them all. So M times M times M times M times M. M to the 5th power. Letter D, this would be 1.2 to the fourth power. And in terms of math, that would be 1.2 4 times. And multiply. One thing you'll notice about me is I really actually don't like using x for multiply. We are in algebra now, and using an x for multiply is kind of like a third or fourth grade way to show multiplication. You really don't see that anymore. I think this is probably one of the only lessons, or maybe this chapter is really the only chapter where you'll see that. After that, there are much better ways of showing multiplication. We could show this like this. We put in parentheses. This would be a common way you'd see this. Sometimes you'll see me use like the dot. In fact, I think I used it once already this lesson someplace for multiply. No. Yeah, right there. Like 3 times 5, you'll see this dot. I use it there as well. That's another way to show multiply, but by far the most common way you'll see multiplication from now on is parentheses like this, where you just see the two things next to each other separated by parentheses. All right, so what I'm going to have you do, I'm going to have you do a couple problems out of the textbook. These come from pages 2 and 3, and they are numbers 1 through 8. So go ahead, pause the video, do these 8 problems on your note sheet right now, and then we'll get back together in just a second and do them together. Okay, so let's see here. It wants us to evaluate these expressions when y is 2. So this one is a multiplication. Again, a letter and a number together like this means multiply. So that says 6 times 2. I'm doing it with parentheses. And 6 times 2 is 12. This says 8 divided by 2. And 8 divided by 2 is 4. Here we have a 2 plus 4, and 2 plus 4 is 6. And lastly, we have 11 minus 2, which is 9. So in each step here, in each problem, I substituted first, then did my answer. I did not do it all as one gigantic step. 6 through 8, write the power in words and as a product. That's what we did in the last example. So in words, this would say 9 to the 5th power. And as a product, that'd be 9 times itself 5 times. So 1, 2, 3, 4, 5. There. 9 times itself 5 times. Number 7 says 2 to the 8th power. I'm trying to think if I spelled eighth right. E-I-G-H-T. Yeah, I guess so. If not, I'm sorry. 2 to the 8th power. And then the way we write that as a product, as a multiplication, would be 2, and I'm going to use the dots here. 2 times 2 times 2 times 2 times 2 times 2 times 1, 2, 3, 4, 5, 6. 2 times 2. And lastly, number 8 would be n to the 4th power. And as a product, as a multiplication, we write it out. N times n times n times n. Oops. Sorry about that, hit the wrong button. Alright, so that is reading and writing powers. Now we're actually going to evaluate some powers. So here we have evaluate g to the 3rd power when g is 5. So we want to figure out what the answer to this is. So the first thing we're going to do is we're going to substitute. So g is 5, so we substituted. Now we can evaluate. I always recommend when you're doing exponents or powers that you write this out. So this means 5 times itself 3 times. Now you do the math. Work your way across. So 5 times 5 is 25, and then 25 times 5 is 125. 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. See? Letter B. 2 to the 7th power. That's what we'll get when we substitute because t is 7. Now we write it out. 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. 7 of them. Now, you work your way across. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. And 64 times 2 is 128. Now, the next two problems are a little bit new and a little bit old. By new, I mean stuff we haven't seen yet in this particular lesson. By old, I mean it's by Algebra 1, you should have seen this already. So we're doing it as a review and as a preview. This one is dealing with fractions. This one is dealing with decimals. What I want you to do is pause the video, write it out, multiply as much as you can. If you get stuck, hit play, we'll go through it together, and then hit pause again and continue on your own. Or when you're done, hit play and we'll go through it together. Okay? Letter C. Letter C should be D is 1/2. So you'd have 1/2 to the 3rd power. So that's 1/2 times 1/2 times 1/2. And when you multiply fractions, the rule is you multiply straight across. So you multiply the numerators together across the top, you multiply the denominators across the bottom, and then you'd simplify your answer if you can. By the way, that is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. And letter D is 3.5 squared, or to the 2nd power. That would be written out as 3.5 times 3.5. Make sure you make this dot a little bit bigger so you don't confuse it for a decimal point. And the way we do that without a calculator is you set it up and down. You do your long multiplication. 5 times 5 is 25. 5 times 3 is 15, 16, 17. Drop down, add a 0. 3 times 5 is 15. 1, 5. 3 times 3 is 9, plus 1 is 10. 5, 2, carry the 1, 2, 1. So we got 1, 2, 2, 5, but the decimal in the problem, there are 1, 2 numbers after the decimal in the problem. It has to be the same in the answer. So 1, 2, decimal goes there. 12.25 is our answer. All right. So that's a little bit of review on multiplying fractions and multiplying decimals. By the way, if you're a little weak on that, fear not. We actually have next chapter, chapter 2. There are lessons specifically on just multiplying fractions, decimals, positives, negatives, all that good stuff. Okay. Example 3. Now we're going to be this is just more evaluating powers. We just have a couple little wordy problems, some out of the textbook, and we're done. So here it says, you can find the number of cells after it had divided using the expression 2n, that's important, 2n, where n is the number of times the cell divided. Okay, so this is the how many times it's divided. How many cells would there be after 4 divisions? So that would be our n. So we give our expression, we substitute, and then we do the math. Now, I don't have space down here. I'd keep working down, so I'm going to bop over here. So this is 2 to the 4th power. I almost wrote 2 times 4. 2 to the 4th power. And that, if we evaluate, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So after the cell had divided 16 times, I'm sorry, after the cell divided 4 times, there would be 16 of them. So basically the way it works out, you have your gigantic cell, a little bit of science here, and then the cell separates into two smaller pieces. So imagine those are now two separate cells. And then each of those eventually separates. So that's one division. A second division would happen where each of those separates. Now we've got 4 cells. And then each of those, so that's 2 divisions, 3 divisions, each of those would separate. So something like this. Now my drawing's starting to get sloppy, but you imagine there's 1, 2, 3, 4, 5, 6, 7, 8 of them, and then each of those separates, and now you'd have a total of 16 cells. If you keep cutting in half and half and half and half, or you're doubling again and again and again, you'd get 16. So yes, that answer makes sense. Letter F, I would like you to copy down and do on your own. It says each side of a square garden measures 22 feet. You're going to buy fertilizer for the garden before you begin planting, and you need to determine its area. Find the area of the garden. Now, I'm going to give you the formula for area, in case you don't remember. So the formula for the area of a square is you take length times width. So if you need to, draw yourself a picture of this garden and then find your area. Go ahead, pause the video, do it now, and we'll get back together in just a second. Alright, so if you did this, you did not have to draw a picture, but I think it comes in handy. So we have this square garden, and it says each side is 22 feet. Now, to find the area, which is the space on the inside of a garden, to find the area, you'd plug in 22 for the length, 22 for the width, and then we'd have to multiply this. Okay, so off to the side of your paper someplace, you take 22 times 22. 2 times 2 is 4. 2 times 2 is 4. Drop down, add a 0. 2 times 2 is 4. 2 times 2 is 4. Why did I go slanty like that? 4, 8, 4. So we got 484 feet squared. Whenever you find the area of something, your units will always be squared because you're taking feet times feet. So you get feet squared. So the area of this garden was 484 feet squared. The last couple problems you're going to see are coming from the textbook. They come from page 4 and are problems 9 through 12. Now, up here I have the problems listed, and this is example 12. It says, in example 5, suppose a storage cube was folded flat. This is the problem from example 5. Okay, so use this information to help you out when you're doing number 12. So go ahead, pause the video, do these 4 problems on your own. When you're ready to continue, hit play, and we'll go through it together. Okie dokie, let's see it. X cubed. So that would be x times, well, let me substitute first, I guess. So it'd be 8 cubed. So that's 8 times 8 times 8. And you probably did this off to the side of your paper. I can do some of it in my head. I know 8 times 8 is 64. And 64 times 8, I was going to do it in my head, but I'll show it out. 8 times 4 is 32. 8 times 6 is 48, 49, 50, 51. 512. Number 10, we've got k squared, where k is 2.5. So we have 2.5 squared. So you take 2.5 times 2.5. It's going to be 6.25, I think. And then 5 times 5 is 25. 5 times 2 is 10, plus 2 more makes 12. Drop down, add a 0. 5 times 2 is 10. carry the 1. 5 times 2 is 4, plus 1 is 5, and we get 625. There are two numbers after the decimal in the problem. It needs to be the same in the answer. 6.25. Letter D. Letter D says 1/3 to the 4th power after you substitute. So that would be 1/3 times 1/3 times 1/3 times 1/3. You multiply across the top, 1. You multiply across the bottom, 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So you get 1 over 81. So that's the first 3 problems. You were just evaluating. You were finding the answer, and I'm going to delete this work, so make sure you got it. Okay, and number 12 here. It says, suppose an example 5. So in this scenario here, the storage cube is folded flat to form a square. Find the area of the square. Okay, so we're trying to find the area of the square. So we're using length times width. Now we've got to figure out what the length and width are. So each edge of a medium-sized pop-up storage cube is 14 inches long. And I really don't need anything else because I'm trying to find the area. And so if this square thingy, each side is 14 inches long, length is 14, width is 14, area is just the 14 times 14. 4 times 4 is 16. 4 times 1 is 4, plus 1 is 5. Add a 0. 4 times 1 is 4. 1 times 1 is 1. 6, 9, 1. 196 inches squared. Again, area is always squared units. In the actual problem they were doing here, they were talking about volume. In case you're curious, volume would be inches cubed, because volume is length times width times height. So you're taking inches times inches times inches. So you'd get inches cubed. In feet, you're taking inches times inches, so you get inches squared. So, the last thing you have to do is in the summary box on your note sheet, it says, how do you evaluate algebraic expressions? Pause the video, see if you can write down an answer to that, a sentence or two. How do you evaluate algebraic expressions? Look back at the note sheet if you need to, and we'll get back together in just a second. Okay, here's what I came up with. I say to evaluate algebraic expressions, you start by substituting the number in for the variable. That's what we did in all of our problems. We got rid of the letter by putting in the number. Then you evaluate, which means do the math. Then you do the math to find the answer. That's what we did in every single problem. Now, homework comes from page 5, and it's just a couple problems from a couple different areas because we want to give you a variety of different problems to try here. So it's numbers 2 through 8, 15 through 19, 24 through 28, 48 and 49, and actually 48 and 49 are on page 6. So, this has been lesson 2.1. Thank you for watching.